Welcome again. I want to bring a topic called measurement, and in this episode I'll be teaching what we call density of mixtures. Density of mixtures. A mixture is made of two substances which do not react with one another such that they can be mixed together. In a mixture, it is also assumed that volume of mixture is equal to volume of the individual components of the mixture. So for example, if we are mixing 20 grams of water and 20 grams of mercury, then the mixture will have a total of 20 of water, 20 of mercury, 40 cubic centimeters. Therefore, the assumption made under determining the density of mixtures is that the mixture will have a volume which totals to the volume of the individual elements making up the mixture. Therefore, from the definition, the density of the mixture will be calculated by mass of the mixture divided by volume of the mixture. The volume of the mixture will be volume of the individual components of the mixture. Mass of the mixture will still be the same. If you are combining 40 grams of water, 50 grams of mercury, then the mixture will have a mass of 40 and 50, totaling to 90 grams. Therefore, we can just take an example so that you may see how density of mixtures is calculated. So let me read out the question here. Then from there we can see how to approach it. We are told, for example, 1800 cubic centimeters of fresh water of density 1000 kilograms per cubic meter is mixed with 2000 cubic centimeters, is mixed with 2200 cubic centimeters of seawater of density density 1025 kilograms meter cube. Calculate the density of the mixture. Calculate the density of the mixture. Calculate the density of this mixture. We have said very well the density of a mixture is given by mass mixture divided by volume of the mixture. From these instructions, what can be obtained directly can be the volume of the mixture, because fresh water is having 1800 cubic centimeters and seawater is having 2200 cubic centimeters, which means volume of the mixture can be obtained by directly adding the volumes of the individual elements making up the mixture. That will be volume of mixture will be given by 1800 plus plus 2,200. And that will give us 4,000 cubic centimeters. Now, because the volume is in cubic centimeters, then we can operate with the densities when they are in grams per cubic meter, and we can convert them. We can convert them by dividing them so that they may change to grams per cubic meter. To divide them by 1,000 means we are told we have 25. Okay, we have 1,000 kilograms per cubic meter. Then how many grams are there in a cubic centimeter? So we can change this one into grams by taking 1,000 kilograms and we multiply them with 1,000. We multiply them with 1,000. This means we will have 1,000,000 grams. So with 1,000,000 grams, we can also say if this is 1 cubic meter, 1 cubic meter is equal to 1,000,000 cubic centimeters. Therefore, now dividing the mass and the volume again to get density now in grams per cubic centimeter, we will divide 1,000,000 and 1,000,000. That is why we get the density of water as 1 gram per cubic centimeter. 1 gram per cubic centimeter. Therefore, for water, fresh water, we use 1 gram per cubic centimeter. And for the seawater, we use 1.025 grams per cubic centimeter. Therefore, with the densities and the volumes, we can get the respective masses. So mass of fresh water, mass is given by density times volume. Therefore, 1 times the volume of 1,800 gives us 1,800 grams. We can also determine mass of seawater. Mass of seawater, which will be given by a density of 1.025 times 2,200. So that you may get the mass 1.025 multiplied by 2,200. This gives us 2,255 grams. So we can get, with that now we can get mass of mixture. Mass of the mixture. Mass of the mixture will be the sum of the two masses of the elements making up the mixture. And this will be 255 plus 1,800. And this will be 4,055. 4,055 grams. 4,055 grams. Therefore, with the mass of the mixture and the volume of the mixture, then we can get density of the mixture. It's assumed that the density of the mixture will be roughly a value between the density of the components being mixed. Therefore, being mixed of 1 gram per cubic centimeter and 1.025 grams per cubic centimeter, which means we will have the density lying in between those two densities. Therefore, density of mixture now, according to this expression, will be mass of the mixture, which is 4055, divided by volume of mixture 4,000. Volume of mixture 4,000. This gives us 1.01375 grams per cubic centimeter, a value which can be converted to SI units by multiplying by 1,000, and this will give us 1013.75 kilograms per cubic meter. Therefore, the density of the meter is given as this value. Thank you for following. Subscribe to Shifting Grades and share the link with your friends. Thank you.